Hello, my name is Dani and I'm going to present a project looking at prospective action imprinting into visual working memory. Memories have been considered to be about the past, but actually they are all about the future. And this can be illustrated in a very simple example. Imagine you enter your kitchen because you want to make a tea. What do you need for that? You need the tea, you need the kettle, and you need a cup. You have to keep in mind the identities and locations of these objects, and you have to maintain them in memory while you move around through the kitchen, because they might not be visible the entire time. Before boiling water, you then have to select the object kettle for memory, and this in turn will guide all your following actions with this object. Hence, this very simple example shows us that memories guide future behavior. Some studies have already looked at this link between memories and actions. For example, Mecklinger et al. Could show that there's a stronger activation in motor cortices when participants had to maintain objects in memory that could be manipulated versus those that couldn't be manipulated. From this, they concluded that working memory for objects recruits motor programs associated with their use. In a more recent study conducted in our lab, Van Eder et al. Examined the question when visual representations and their associated actions become selected from working memory. Surprisingly, they could find that visual and motor information is concurrently retrieved from working memory. However, a question that still remained open was when action plans become integrated into working memory, and we addressed this question with the following task design. Each trial started with a pre-cue, which matched in color with one of the following presented bars in the encoding display. Participants had to encode the orientations of these bars. After a delay, a 100% valid probe was shown, and then participants could initiate their response. The dial appeared, and participant reproduced the cued orientation with keys on the keyboard. Critically, there were three key features of our task, and the first one can be found in the response window. The dial people used to adjust the orientation of the cued bar could only be rotated up to 90 degrees to the left or 90 degrees to the right. This means that only the left hand could be used to reproduce leftward tilts, and only the right hand could be used to reproduce rightward tilts. This independent manipulation of response hand, which is the motor feature of our task, and item location, which is the visual feature of our task, allowed us to track corresponding brain activity separately. Next, as compared to Van Eder's first study, we also included a pre-cue, and this pre-cue allowed us to monitor brain signatures from the time of encoding on. Lastly, we also manipulated the delay period. There were expected early blocks, where the delay was 2 seconds long, and expected late blocks, where the delay was 4 seconds long. And this predictable delay allowed us to separate action imprinting from action preparation. And I will explain in a minute what I mean by that. Our main dependent variable was motor recruitment. Motor recruitment is the lateralized power of mu alpha and beta activity relative to the eventual response hand in the motor electrodes. And here we have a short example. So imagine participants have to reproduce a leftward tilt. That means they have to use their left hand. Then we would predict or expect contralateral suppression in the motor cortex. So here what is indicated in blue. We considered two alternative scenarios that could explain the pattern of motor recruitment that we will find in our data. In the first scenario, we considered that action preparation develops gradually and is fine-tuned to the expected time of memory utilization. In addition to that, in the second scenario, the action is also imprinted into working memory, and this happens regardless of when the action is actually needed. So we have at first this action imprinting, and then the gradual action preparation, which is then fine-tuned to the expected time of memory utilization. So let's have a look at our data. Here we can see the time frequency results both for expected late and early blocks. And what we can see here is that motor recruitment was shown or occurred throughout the entire delay period. If we split this now up into expected early and expected late trials and look at the mu alpha and beta frequencies, we can see an early action imprinting effect, which is followed by gradual action preparation. You see that here when the lines diverge. And this matches quite nicely with our second scenario, where we at first have this action imprinting effect that happens regardless of when the action is needed, and then followed by this fine-tuning of action preparation. Thus, we concluded that early action imprinting is followed by gradual preparation of the prospective action. Next, we performed 3 critical verifications of the action imprinting effect, and I will walk you through these now. First of all, we wanted to know if we still get this action imprinting effect, even if the motor system is engaged in a secondary task during maintenance. This is quite important to consider because usually when we perform a working memory task in real life or in daily life, we don't just encode something and then wait to perform the action. Usually we do stuff in between. For example, when you boil the water and you put the kettle on the stove, you just don't wait for it till it's done and then perform the action that is associated with the kettle. Usually you do something in between, like taking a bite of this delicious cake. And this is what we studied in our second experiment, which is quite similar to the first one, but we included an intervening motor task in the delay period. And here, squares appeared either on the left or the right of the fixation cross, and when the square appeared on the left, participants had to press left button on the keyboard, and if the square appeared on the right, participants had to press the button with their right hand. And this task was completely independent of our working memory task. These are our time frequency results for the entire spectrum, and this is a cutout for the 8 to 30 Hertz frequency range. And we can see here for the 400 to 800 milliseconds interval, again, this early imprinting effect. And this is quite striking because this even occurs when participants have to engage into a secondary motor task in the delay period before reproducing the tilt of the bar. Thus, we can tick our first box here. Action imprinting even occurred in phase of an intervening motor task. As a next check, we wanted to know if these action signatures that we found really reflect anticipated task demands and not only merely the visual tilt or visual attributes of the stimulus. For this, we included a visual localizer module between blocks. Here, participants just leaned back, fixated on the fixation cross, and bars occurred or appeared either on the left or on the right of the fixation cross. As compared to the motor recruitment pattern that we could find in motor electrodes in response to the task, we couldn't find any in response to the visual localizer. And from this, we concluded that action imprinting really reflects the anticipated task demands and not only the visual stimulus. As a last check, we wanted to know if action imprinting is also behaviorally relevant. For this, we split our reaction time data into fast and slow trials. And here we can see that there was a stronger action imprinting effect when participants responded fast after 2, 4, and 6 seconds as compared to when they responded slow. And if we look specifically at the 400 to 800 milliseconds window, we see that this effect, we see that the action imprinting effect was significantly more pronounced in the fast trials as compared to the slow trials. Thus, the action imprinting effect predicts behavior or performance even up to 6 seconds after encoding. Coming back to our main question, asking when action plans become integrated into working memory, the answer is immediately, and it happens despite an intervening motor task. It's reflecting anticipated task demands, and it also has behavioral relevance. And with that, I would like to thank my collaborators and you for listening. Thank you.